In this video we're going to be checking out how to express numbers as a product of their prime factors, and we're going to do this using factor trees. So first of all, let's check out a few definitions. So a product is what you get when you multiply two or more numbers together. A prime number is a number only divisible by 1 and itself, and a factor is a number that fits exactly into another number. Okay, so this is useful for finding what's called the highest common factors and lowest common multiples between numbers, but we'll check that out in a different video. We do need to know how to do this to be able to do that. So without further ado, let's say then that we're asked to write 24 as a product of its prime factors. Now, as I said before, we're going to use factor trees. So out of 24, we're going to draw two lines like this. Now, the idea is that at each level, we find a prime factor. So, with 24, 24 is an even number, so we can take out a factor of 2. And it's a good idea to circle your prime factors so that they don't run away, because they like to do that. Now, when we take out a factor of 2, what we're doing then, we're dividing 24 by 2, and that will leave us with 12. Now 12 is not a prime number, so we carry on and do exactly the same to 12 as we just did to 24. So again, 12 is an even number, so that means that we can take out another 2, put a circle around it, and then 12 divided by 2 is 6. 6 again is not prime, so we can do the same. Now 6 is equal to 2 times 3. Now 3 is a prime number. So once we get to this point where we've got two circled factors, two prime numbers, this is where our tree ends. And this is how we get our answer. So we can say that 24 is equal to 2 times 2 times 2 times 3. So all of the circled numbers multiplied together. And then we can sharpen that up a little bit. 2 times 2 times 2. We would write 2 to the power of 3 times 3. So that's our answer there. 24 is equal to 2 to the power of 3 times 3. Okay, so what's going on there? 2 times 2 would be 4, times 2 is 8, and then times 3 is 24. Job's a good one. Okay, what about if we go for 45? Okay, so we want to express that as a product of its primes. So 5 goes into 45 9 times. 9 times 5 is 45. 9 isn't a prime. We can write 9 as 3 times 3. So we could say that 45. Now when you write your answer, ideally you always want them to be in ascending order. So start with your smallest factors first. So 3 times 3 times 5. And then we can sharpen that up to 3 squared times 5. There's our answer. 45 is equal to 3 squared times 5. Alrighty, what about if we go for 70? Okay, so first thing that I spot there is that 7 goes into 70, and 7 is prime. 7 goes into 70 10 times. And then we want to split 10 up. Well, 10 is 2 times 5. There we go, we've got to the end of our tree. So in ascending order, 70 is equal to 2 times 5 times 7. And we can't simplify that at all because all the factors are unique. So job done for 70, 2 times 5 times 7. What about 36? Okay, well again it's even. So we know that it's 2 lots of 18. So 18 isn't a prime number, but it is even. So again, we know that we can take a 2 out of 18. So 18 is 2 times 9. 9 isn't prime. 9 is 3 times 3. So then we can say 36 is equal to 2 times 2 times 3 times 3. Now that we can sharpen up and say it's equal to 2 squared times 3 squared. So 36 is equal to 2 squared times 3 squared. Now, it's not necessarily true that you have to take out a prime factor each step. We can actually do it by taking out not primes. So, for example, let's do 36 again. So we might spot that 36 is the same as 4 times 9. So neither one of those are prime yet, but there's no problem. We just come off with a 4 and write 4 as 2 times 2 and 9 as 3 times 3. So again, we've got our 2 times 2 times 3 times 3, which is 2 squared times 3 squared. So you don't have to take out prime factors at each step. Okay, let's do a couple more. Let's go for 56. Okay, well 56 is a multiple of 7 and 8. So let's take out a 7, which is prime, and an 8, which is not. So 8 we could write as 2 times 4, and then 4 finally is 2 times 2. Okay, so we've got 56 is equal to 2 times 2 times 2 times 7, which we can write as 2 cubed times 7. 56 is equal to 2 cubed times 7. Let's go a little bit bigger. Let's go for 128. Let's see what happens there. So, it's a bigger number, but it's not really that scary. We're not too worried. So we can say that 128 is 2 lots of 64. 64 we can say is 2 lots of 32. 32 we can say is 2 lots of 16. 16 we can say is 2 lots of 8. Now 8 we can say is 2 lots of 4. And then finally 4 we can say is 2 lots of 2. So we can say that 128 is equal to all of these 2's multiplied together. So we've got 2 times 2 times 2 times 2 times 2 times 2 times 2, which we definitely want to smarten up a little bit. So how many 2's have we got? 1, 2, 3, 4, 5, 6, 7. So we can say our answer is 2 to the power of 7. Okay, let's do a couple more. Let's go for 94. Okay, so 94 again, it's even, so let's take out a 2. And half of that then would be 47. Now 47 is actually a prime number. So 94 finishes really quickly and is 2 times 47. Can't simplify that at all. What about if we go for 99? 99, we could go for 3, which goes in 33 times, and then 33 we can split into 3 and 11. So 99 we could say is 3 times 3 times 11. 3 times 3 we could smarten up as 3 squared. So we get 3 squared times 11 as our answer. Okay guys, I think that's enough. So I hope it's useful. Check out the next video on the highest common factor and lowest common multiple. don't forget to subscribe and take it easy. Cheers guys.